Hello, Assalamu alaikum everyone. My name is Ahmed Uzair and I'm part of Faana Executive Board. Faana, as you know, is FAST Alumni Association of North America. Over the past decade or so, Faana has been involved in a variety of initiatives across all five campuses of FAST, ranging from scholarship funds to research fund and closely working with the campus on developing the curriculum and enforcing new policies. Webinars is one such initiative where we try to bring alumni from various industries and conduct sessions on their areas of expertise. The goal of these sessions is to shorten the gap or the divide between the industry and the academia, and at the same time provide source of motivation for the existing and recently graduated FASTians. Our today's guest speaker is Mr. Muneeb Hasan, who is an alumni of FAST Islamabad Batch 2001. He has over 15 years of experience working in IT industry and currently works as a solution architect for Protegrity. He is currently based out of Atlanta, Georgia. Um, Thank you very much, Muneeb, for joining us today and taking our time from your busy schedule. We really appreciate it. And without any further ado, over to you. Thank you.
All right, thank you very much for having me. Hello, everyone. Let me share the screen. All right. So, um, as Uzair mentioned, the topic for today is data warehousing on-prem to cloud. How I'm going to be talking about the journey of data warehouse from where it started from on-prem and where it is right now, which is on the cloud for the most part. A little bit about me before we get started. I completed my bachelor's in computer sciences back in 2005 from FAST Islamabad, and I did my MBA from Georgia Tech in 2017. And I have more than 15 years of consulting experience in data analytics. I started working out of college for Teradata in Pakistan, and worked as a professional services consultant as well as solutions architect for almost 13 years. Then moved over to Informatica, which is a data integration company. I spent a couple of years over there, and currently I work as a solutions architect for North America at Protegrity. Protegrity is a data security and privacy company. So the agenda for today is basically I'm going to be going over the overview of data warehousing, how the differences are between on-prem versus the cloud data warehouse, and how the cloud data warehouse has helped sort of accelerate the data analytics part. And I'm going to talk about some data security part as well. So before we dive deep into the session, I would like to take a couple of minutes to talk about this. So as you can see, there are in any given day around 500 million tweets sent out. 490, 294 billion emails are sent out. You have 28 petabytes of data being generated by variable devices every single day. It is estimated by 2025, 463 exabyte of data will be generated in any single day. If we just think about these numbers, these are just data points. They don't really mean anything if you don't really make sense of this data. The real value that you gain out of is if you understand and sort of connect those data points to something useful. And for that, we use data warehouse. So historically, data warehouse, the idea started back in the 1970s, but got more traction by 1980s, and more implementation started coming around 1990s. So basically what data warehouse is a repository of data coming in from multiple sources. It can be any type of source. It can be customer usage data. It can be customer data by itself. It can be billing information, financial data, call center records. Once the data is sort of consolidated, it is processed, it is transformed, and it is ingested by the data warehouse. And from there, business users can come in using their BI tools or SQL clients to generate reports, understand what sort of what that data means, gain meaningful insights, and make good use of the data that they have received, and then take actionable items, what course of action they need to take to perform some improvements, or reaching out to different customers, whatever they want to do. Data warehouse in itself is a blend of technology, so you have to pick and choose what sort of database that you want to use at the back end, what sort of tools that you need to use, so that your team is successful in trying to understand and gain the meaningful insights that you're looking for. So one of the questions that comes in, why data warehouse? And especially in this day and age, a lot of people don't really care about data warehouse. All they care about is data analytics, on machine learning algorithms on top of something. But you have to keep in mind why data warehouse in itself is still relevant right now, and why it's very, very important. A data warehouse helps you making well-informed decision, and the data that comes in is consistent. You can have the same set of data spread around across your organization, or you can have it in a centralized data warehouse repository. That way you get rid of the data which does not really make sense. It's consistent, and the data quality is better as well, which helps you with the improved business intelligence. You go with the facts and understand what that data means, and then make decisions based on that. Data warehouse also helps with quick response time, especially in this day and age. You have so much data being generated. You need to make sure that whatever decision you need to make it fast. And for that, you need to have the data available all the time with you. It also helps with data mining. You can dig up more insightful or useful insights using data mining techniques. And data is the core for machine learning algorithms. You need to have good set of historical data to run your machine learning algorithms, to find patterns in your current scenarios. Uh, we'll talk a little bit more about this in the future slides. So this is sort of a basic architectural diagram for a data warehouse solution. And again, this is not going to be, this is not something that you'll see everywhere. Every company I have worked with, over 25 customers all over the world, and I have seen different set of scenarios in all of them. So this is sort of an high level architecture. You can have a different setup at your organization. You have data coming in from different data sources. The operational systems are basically, it can be either your Oracle systems, your mainframes, or anything which is currently running, generating data. It can have billing information, it can have financial, customer, call center data, or you can also ingest flat files like CSVs, or just plain text files, comma separated files. You load them into the staging area, uh, and from staging area, you transform them using the business rules defined by your business users over to the warehouse. And in this particular step is called ETL, extraction from the data sources, loading it into your data warehouse and transforming it on the fly. So it can be ELT or ETL, both of them work. Once the data is in the data warehouse, your business users can come in, run their analytics on top of that, run reporting like on business intelligence tools like business objects or MicroStrategy, or perform data mining using queries. So this is another setup for sort of a similar architectural setup. In this one, I have added a data mart. And the reason for doing this is to separate different business users to access only specific data mart that they need to use. instead of going to the data warehouse and accessing the whole warehouse. So sometimes, let's say, sales don't really need to see what's under inventory. So that way you can block the access for them. So let me quickly talk about some of the benefits of data warehouse. So you have a centralized repository of your data. You can create standardized reports with actionable steps. So you can understand what your current scenario is. You generate a report which can help you, uh, let's say, for example, savings for your research, right? You already had the data which showed you that the research that you previously did yielded this amount of revenue. So maybe you were doing something wrong, which now you can understand looking at the data, and you can improve on that process. Similarly, you can develop and sell products, which means if, let's say, you understand the customer's wants and needs using the data, you can then create better or create and develop better products to sell to those customers. You can answer ad hoc questions like, what region is the most profitable region for me, or which segment of customers are more prone to purchase a different segment. You can track metrics and KPIs. These are really important. So let's say one of the key performance indicator for Amazon would be to make sure that our customer satisfaction is dependent on a 2-day shipping delivery. So they have to make sure that they are delivering to their customers within 2 days. If they fail on that KPI, then the customer satisfaction is bound to go down. And using the data, you can actually devise strategies which are based on facts instead of just strategies based on uh, discussions. Or if I feel like this strategy would be much better, I would go with that. No, you need to have data to back the strategy that you want to go with. So here are some of the industries which initially went with uh, uh, data warehousing. They were the early adopters, and there are some other companies as well, but I just put in as an example some of these. Like for example, Walmart was one of the first companies to actually achieve 1 terabytes of data, and one of the reasons for that was the transaction history that they were generating from their point of sale systems. It ended up generating a lot of data, and it really helped them running analytics on top of that, or understanding the customer behavior. So one of the things that they did was to see what are the products that customers buy the most, which was like, let's say, grocery items, bread, milk, eggs. And once they figured that out, they put those items at all the way at the back of the store. And the way it helped them was it increased a lot of revenue, because people used to walk all the way down to the store, and in between they would end up buying something else through the aisles. Similarly, for airline industry, the way they priced their ticketing on holiday season, using data, historical data, they would be able to identify which weeks or months or days would have more traffic. They would price them accordingly. For AT&T, Bank of America, similar scenarios, they help their call center teams to get the historical data on customers at runtime, so that way the customer call center teams or associates can deal with their customers in a much better manner. So I'm going to stop here for a couple of minutes. Are there any questions? I can quickly answer those and then we can move on. Is there? If not, then let's move on. All right. So on-premise data warehouse versus in the cloud. Um, so basically, the data, let me first explain what on-premise data warehouse really is. On-premise would be a data warehouse with a huge server at the customer location, and you would have to have a dedicated room to make sure that the room temperature is perfect 24/7. There is no downtime if you have to have a hot standby node or nodes to make sure that there is no downtime and everyone is using that. The the basic and disruptor, like any other industry, the data warehouse industry was bound to be disrupted as well. One of the major reasons for its disruption for on-prem data warehouse was the cloud computing. There is a webinar by Atal Haq, who did a cloud computing webinar recently. I would suggest go and read up on that or listen to that. It covers really good scenarios about how cloud computing is changing the way we do work. And similarly for data warehousing, it was the same thing. Why do you have to spend a lot of money to buy a system which might not be able to utilize everything for the first 2 years? Like let's say you spend $10 million on a system with storage and CPU, which is going to be used like 30% for the first year, 50% for the second year, 70% for the third year. You can start small. You can just buy in with the cloud storage and cloud compute, and then grow as your business grows. Uh, Another important disruptor was Hadoop. The Hadoop ecosystem came back in, I think, 2008, 2010, somewhere around that time. Um, Hadoop in itself is dead now. There are no more companies giving you the product Hadoop. MapR was bought off by HP last year. They just got the IPs and copyright and got rid of MapR. Cloudera and Hortonworks merged last year, and now Cloudera does not provide a Hadoop solution. They provide a CDP, which is a Cloudera data platform. But the ecosystem is there. You can still get it from Azure HD Insight or AWS EMR. The good thing about Hadoop was the open source platform. Anyone can come in, either create a project of their own, or they can just start performing their analytics, dump the data on top of Hadoop, and start using or performing their analytics. Um, and that was really important because earlier people used to work with relational databases and work with structured data sources, but that all changed when you had mobile data, web data, everything else coming in. It was unstructured. People didn't really understand how to make sense of it, and there was no way of storing it with the traditional databases or data warehouse. So Hadoop helped in that sense. Um and Definitely it was open source. You don't really need to have proprietary servers, so it was really cost effective as well. Other than that, same things. SaaS model also changed. The pace of innovation is much more quicker when you don't really have to follow protocols. You don't have to perform certifications. You can just get started with whatever you want to do. Operational expense, definitely another issue. You have to have a good managed services team, operations team. You have to make sure that everyone is available on site. With cloud computing, that's also something that you can reduce your cost quite a bit. Now, some of the benefits of cloud data warehouse. Again, I would suggest go and check the session by Atal Haq, but on-demand scalability that I touched a little bit earlier about. You can grow your business, or you can grow your solution with your business. The more business you're generating, the more revenue you're generating, you can grow your data warehouse solution as well. It's cost efficient. You don't have to pay $10 million upfront. You can start off with $2 million the first year, $4 million the next year, and $6 million the third year. Eventually, you might be spending a bit more, but upfront cost is going to be less. All right, let me quickly talk about some of the cloud data warehouses available out there. First one, Snowflake. It came 3 to 4 years ago. and it is one of the fastest growing companies right now. One of the differentiators that they had back in the day, not right now, but back in the day, was they separated the storage with compute, and this was really important and sort of a game changer at that time, because most of the companies used to, if someone needs more storage, they would have to buy a node which would still contain compute and storage, and the compute which was not required would become redundant for the customer. On the other hand, Snowflake with Snowflake you can just buy both of them together. Another great feature is time travel. Time travel, what it basically does is it keeps a snapshot of your data warehouse for up to 90 days. So if, let's say, um, you're running your jobs and after 30 days you realize all of your data for the past 30 days is wrong, you need to go back to the like 30 days ago or a month back. You can just completely use that snapshot from 30 days ago. Obviously it comes with a cost, and you have to pay to keep the same snapshot of your data warehouse every single day, but it's still a neat feature. Secondly, you can also do a quick copy of your data. As I mentioned earlier about the data marts, you have multiple teams, multiple data science teams working with you. You need to make a copy of your data warehouse. You can simply uh, quickly copy it over to a different S3 bucket and have your team start using that particular warehouse or data mart instead of using the same centralized one that you're working with, and it happens within minutes. So that's really good, instead of on-prem servers where you have to contact the company, then they will ship it off to you. It will take weeks or months to get you set up. With Snowflake, you can get started within minutes. AWS Redshift, this is also one of the older cloud data warehouse platforms provided with by AWS. The one of the good features about this is it's the same AWS ecosystem. You can pretty much pick and choose other AWS services and get started fairly quickly, just like Snowflake, within minutes. Like you can have streaming data coming in from AWS Kinesis. You can use Amazon EC2 instances. With Redshift, you can have data stored on Amazon S3 buckets, and you can sort of do the same thing using AWS Aurora. You can hit the S3 buckets directly and perform your analytics on top of that. I would say one bad thing about this is you're locked down on AWS platform. So if, let's say, your organization works with AWS but they want to switch over to Azure, you'll have to change all of your solution completely. With Snowflake, you have the option of deploying it on all three major cloud vendors like AWS, Azure, or GCP. In last year with the data warehouse solution. Similar to AWS, you can have Azure, same ecosystem with other Azure services, Power BI, Azure Data Factory, HD Insight. It's very seamless, good integration. It was actually created by ex Informatica people, so they understood the pain points that the developers go through, and that's why it's much more easier to use. But same issue, if let's say your company wants to move on to a different cloud platform, then this becomes useless for you. GCP BigQuery, it's it's more of a analytical platform. You can have a data lake as well as data warehouse all merged together. You can use Tableau, ClickView, other things for BI tools, but same thing, single platform. And finally, Teradata Vantage. So Teradata used to be a data warehousing company, but while I was there, they started transitioning towards more analytical platform, and this is their solution. The good thing is you can deploy it on all three cloud platforms, just like Snowflake, and you can pretty much use any analytical tools with Teradata Vantage. It has Kubernetes, Docker containers, sort of a structure, so you can add any other. Let's say you have a machine learning engine or you have TensorFlow engine, you can also add that as part of your Docker. That way you can have very quick response times to all the queries. And instead of writing your code in Python or Java or uh, any scripts in R, you can simply use SQL to execute those. You don't really necessarily need to know those languages, which is another neat feature for this. All right. Again, I'm going to stop here before I move to the last section. Are there any questions? Okay, I think Uzair is muted. Let me unmute him. Okay.
Uh, I think we have one question over here. I'm not sure if we should take it towards the end, but uh, Noman Jilani is asking, I graduated from FAST in June 2020. I've been working as ETL developer for last 7 months. I came to know that there are multiple tools for ETL, SSIS, and Informatic. Do we need to know and learn about all of them?
That's a good question. Not necessarily. You need to understand the concept of what an ETL tool does, which is quite simple: extracting data from the sources and then transforming it using any business rules that you have, and then loading it over to some other place. That's the basic concept, and that's how all the tools work. If you understand this properly, then it's not going to be that difficult to learn any new tool. Secondly, it's generally a good practice to learn at least 2 to 3 different tools, just for your own. If you're going to be in the market in the future and you might have to work on a different tool, it's better to learn at least the top on SSIS, Informatica, Ab initio, maybe data stage. That way you have an understanding of how different tools work.
Okay, thank you. Yeah, I think we'll just go along with the presentation, and I'll save the rest of the question for the last.
All right. Okay, so data analytics and beyond. So when we talk about data analytics, it can be also divided into 3 different parts: descriptive, predictive, and prescriptive. So descriptive analytics is mainly what it shows you what happened previously. Predictive analytics talks more about predicting how, using the historical data, predicting how or what course of action you should be taking. And prescriptive analytics is the action that you're taking based on the predictive analytics. Data analytics involves some of these things. Data warehouse, as we discussed, the more and the better, the cleaner data that you have, the better analytics and results you're gonna receive. Data lake, this concept that came with the advent of Hadoop. This is also very important because data lake contains unstructured data, or it can even contain structured data, but data that might be cold storage. Meaning, if let's say I want to run my analytics on top of the data available to me in the past 5 years instead of 15 years, I would just have the 5 years data to be executed my analytics on, and keep the rest of the data in the data lake, because data lake is generally a place which is a much more cheaper storage mechanism. Then using the right tools and technologies is also a key to success for data analytics. Like, let's say I want to uh, get some specific trends from historical data. Using let's say R for statistical regression versus machine learning algorithms, which would make more sense for me for a particular use case, and why. So using the right tools and technologies is definitely very, very important. And techniques like I just mentioned are machine learning or whatever techniques you want to use for performing your analytics. This is a sort of an analytical maturity curve for any organization. They start off with basic reporting to understand what happened from using the historical data. um, then the next questions, once they start getting a bit mature, would be why did it happen, and that is generally answered using when you are mature enough to have your jobs running on a daily basis, which most of the companies are generally in. You have batch jobs running every day, data is coming in, your business users come in the morning, they use the reports and understand why did something happen. The next sort of a maturity a company goes to is exploratory analytics, and this is where things get exciting, which sort of tells you what may happen. It sort of a predictive analytics. And then from there on, you go into prescriptive, which is more of a real-time analytics, understanding what is happening right now at real time and what action should we take. More of a using if you have apps or you play games on the computer or online games, this is sort of what or even social media. Social media is all about real-time analytics, right? So this is sort of an architecture of real-time insights, as you can see. So let's start from the top. You have streaming data coming in from video or voice recognition. You might have some more streaming data like social media data, Twitter information coming in. You have, let's say, Kafka connector, which streams the data right over to your real-time processing engine. But that data is also going to the to be dumped at the data lake, and from that data lake it is going into the data warehouse. Now data warehouse is getting data from the data sources, the same data sources that we discussed earlier, and using that data it will help the real-time processing engine to make sense of whatever action they need to take or any notification they need to send or a real-time dashboard that they need to update. Similarly, a machine learning engine would require data from the data warehouse, or sort of a data analytics would require that the machine learning engine is going to receive data from the data warehouse, and then the data analytics will be updated, and the dashboard with historical data is going to have all the results. So let's talk about some of the use cases, some of the famous ones. Retail industry, we talked about Walmart a bit earlier. Walmart is also doing a lot of good things. Walmart Labs, I think there was a session by Hamza, webinar, go check it out. But Amazon, the way Amazon differentiates between with Walmart is Walmart has tremendous amount of data, but they cannot identify a customer at individual basis. They can group them together, but they cannot identify it at a customer individual basis. And the reason for that is with Amazon, you're required to have your profile, your you know, yeah, what do you call it? Your you have your own profile, each individual who is shopping on Amazon. So you have to so Amazon can actually market you products based on your usage pattern instead of just marketing you based on a group of customers. So that really makes them much better. That's why in retail industry, if you see, Amazon is winning against every other retailer out there. For financial sector, one of the key data analytics use case is the fraud detection. Using machine learning algorithm, banks are using historical data, like let's say 20 years of past customer data, then checking out all the customers who committed fraud, and then with the current customer base, you can find the similar patterns between current and the historical data, and then see which customers are bound to commit fraud, and then they can stop them before they actually do that. Social media is a good example for data analytics. Google, Facebook, these companies were some of the earliest adopters of data analytics. The way they perform ads, again, same thing as Amazon. They have understanding of each individual customer uh, on a uh, on a very individual basis, so they can give you more targeted ads. So a company, if they want to run ads on Google or Facebook, they don't know the exact customer. All they provide the information for is, I need to run ads for this particular segment of customers based on in this region with this age group. And Google and Facebook would do it under the covers. And obviously they can add more categories about, these are the likes and dislikes of the customers that we want to market to. So Google and Facebook is going to manage it. Facebook also does, and I'm pretty sure Google also does that, the deep learning algorithms for your face detection in the pictures. So if you probably have seen or noticed, a lot of times you get a suggestion to tag yourself or tag someone else, and the way it works is they have so much data or pictures of each user that they can, using deep learning techniques, identify those users and then help you tag them. From media, Netflix was one of the earlier companies that use data analytics. House of Cards was a good example. I did not use Kevin Spacey for obvious reasons, but the way they uh, used data analytics for House of Cards was, House of Cards was a famous TV show, British TV show back in the day, and they wanted to start a US based one, and they ran analytics to see, for people who liked that British show, which are the actors and actresses they would like, they also like. So they casted all those actors and actresses in this show. And this is just one example. There are tons of other TV shows that Netflix has created, like Orange is the New Black. It was based on Prison Break's analytics. So Prison Break was a very famous show. They did the same thing. Orange is the New Black, based out around a prison, and there were a couple of other analytics on that as well. Communication for every company, churn is a major issue, and same thing for telecom companies. People leaving in the next few months, they need to know, identify them, and make sure that they don't run away. uh, so what telecom companies do is, they, similar to fraud detection, they run machine learning algorithms, see the patterns of the customers who left after 3 months, and run it against the current customer base, and make sure that if some customers are coming in that particular list, they would send them special, uh, let's say some special offers, or they lock them down for another year with a much better rate, so that they don't leave them in next few months. Gaming. Gaming industry, as most of you know, is one of the most profitable industry right now, and there is a lot that is required while developing a game. There was a session by Mohsen Hassan. If you guys are interested in game development, you can go and see. But he talks about how rigorous that process is to go through developing a particular game. So data analytics, the way it's helping is, it's easing the way you develop a game. It helps you understand the customer or gamers needs, the what gamers really like to see in a game, and that way you can improve on the gameplay. And with mobile gaming, online gaming, you have so much data being generated at runtime, and you might have seen, you see an update for a game, and then after few hours or maybe a couple of days, you see another update. And the reason for that is, if there is an update, They collect the data, run the analytics on top of that, see how the gamers are faring around it. Are they satisfied? If not, then they quickly send out a new update to make the improvements. Healthcare is sort of a new industry. They used to have a huge pushback because they were not really happy to share the um, patient data, but now they are more. They're getting more comfortable, especially seeing the benefits analytics have provided. A lot of companies are getting into performing analytics on top of the patient's data. And as we have seen with COVID, there were so many different models based on how COVID is going to spread. And if we are going to perform some protections, how is that going to change the infections and deaths we're going to have versus if we don't do anything? Now, if for 19th century or 20th century fossil fuel was the most valuable asset, then for 21st century data is definitely the most valuable asset in the world. Whoever holds the most amount of data is the king. You can see Google, Facebook, Apple, Microsoft, all these companies. What is common in them? It's all about data, and they acquire companies where they see a lot of people like Facebook acquired WhatsApp, Instagram, Microsoft, LinkedIn. So companies are going after data. It's all about data, and with that comes the issue of security and compliance. Right, in 2019, more than $2 trillion were lost due to cybercrime, and data breaches since 2013. It's been more than 14.7 billion. So why is that happening? You hear about Marriott, a lot of user information has been lost, Equifax. The data, the security is there. You have network security, you have endpoint security, application security, but the only way to actually secure your data is by securing the data asset itself. And since I am working for Protegrity, I got to understand this in a much more detail. So I would like to just quickly talk about it. So if let's say you have Jon Snow, um, you can encrypt that data, you can tokenize it, hash it, or mask it out. The way it works is, and all of these are supported by Protegrity. The way it works is this is the original data that is coming in from the source. And when you store it in your database, it would be stored like this. So even if some hacker gets hold of this data, it's pretty much useless for them. They cannot do anything. They cannot make sense of this data. And even within your company, if there are any internal hackers or people who should not have access to your data, this is also going to help in that manner. So if let's say someone from a help desk team wants to access data, they don't really need your credit card information, right? So all they can see is the last four digits in the clear, the rest is masked out. Other information can be provided to them. But someone in finance doesn't necessarily need to see other information except for your credit card information and your name. So the rest of the information is going to be not available for them. So if someone is interested to talk a bit more about data security and protection, just drop me an email. We can discuss it after the session. Opportunities in data analytics. So especially for the final year students, if you are thinking about final year projects or anyone who is interested in getting more into data analytics, here are some of the industries. Healthcare, as I mentioned, there are some things being done, but a lot of opportunity out there. I think Irish had a webinar on healthcare. Do check it out. He talks a little bit about why or what sort of AI and analytics are being done in healthcare. Government is generally slow to change. They are not really open to jumping onto new technologies. But recently, you guys might have heard about Azure cloud services. making a deal with the government of the US for $10 billion. And that's just one step. A lot of other countries are probably gonna jump into this as well. It's more of a private cloud versus a public cloud, but tons of opportunities if you can actually convince someone from the government to actually work with you. Education, this is very interesting because due to COVID you have seen a lot of kids. I'm not talking about distant learning. University students have already been doing this for quite some time, but for the kids, they have to, they are now doing virtual study and they are not able to do it properly. I have a 6-year old and I have seen her, she cannot stay in front of the computer to study for more than 10 minutes. So if you have a class of 30 minutes, then what are you going to do for the next 20 minutes? So understanding how each kid responds to a content, that would definitely help in sort of uh, individual learning versus having a class. That class model is probably not going to work for kids. So have a more individual learning, 10 minutes of screen time for study, 5 minutes something else, then come back, you know, again, use analytics, understand, get the insights, and then develop something around it. Agriculture is a new field. It's a great field. Now a lot of companies or people, countries are doing agriculture farming inside, indoors, using IoT devices. You can get much better insights, understand how your crop is growing, and then make it much better. IoT connected cars. Osman did a self-driving car session and he touches a little bit about but he talks a good deal about how data is being generated. And similarly for IoT devices, IoT is the future. Like next 10 years, this is gonna, especially with 5G implementation, these things are gonna go really it's gonna generate so much data that we won't even understand how to manage it. So definitely, if let's say for connected cars in the next 10 years, if majority of the cars are connected cars, then they would be communicating with each other, understanding what sort of traffic, which we already see that Google Maps shows you at runtime if there is a traffic jam fairly quickly. And it's all based on data analytics, using all the data collected from different devices. And lastly, augmented reality, virtual reality. These are some of the fields, again, main fields just like IoT in for the next 10 years. But you can not only find insights for the virtual reality world or using augmented reality, you can also you do data analytics using these technologies. By that, what I mean is you can actually see a map using within your virtual reality environment as seen over here. You can just start touching and expanding on those different data points and then get the insights directly visually, which is, you know, much more interesting to do instead of just checking out reports or running Tableau. So just to summarize of what we discussed today, I showed you what's the value data warehouse brings, how cloud computing empowered us to use more data analytics, and how techniques like machine learning can help you and your organization be successful. Thank you very much. And here are my contact details. You can drop me an email or you can connect with me on LinkedIn. And now with that, I'm open with for questions.
All right. Thanks a lot, Muneeb. It was a very well done session, and I think it covered a lot of aspects in data warehousing. So that's a great for somebody looking for some lead in information into this topic. We have a bunch of questions. So I'll start off with a couple of questions from Zuberia, Ayub, and Javeria. They are both the questions are more or less same. So I'll just lump them together. How beneficial will it be to take data warehousing course during undergraduate? And then Javeria asks, if somebody has not taken any data science course in undergrad, where should they get started from? Masters in data science, question mark.
Um, so for the first question, definitely if your undergrad degree has a course, go for it. If you are interested, one thing you should always remember is you need to have a passion for something. If you have a passion for it, go for it. Just, but if you don't have a passion, just doing a degree course or going for something that you don't really understand, I would not recommend that. But if you have an opportunity, go take a course. If you like it, you will definitely, and that would also help you understand if you really want to pursue your career in something like data warehousing or not. So go take the course. For the second part, if you have not taken a course in your undergrad, do you want to do it in your do a master's degree? Same thing. I would suggest first go read up. There's so much data available online. You can have courses on YouTube. Read up on this. Try to see if that's something that you really like to do. And if you do, then yes, you can go and do your master's degree in it. But I would first suggest, recommend, go and read up on it and see if that's something that you can connect with.
The next question is, why was Hadoop an open source project taken down? And then a follow-up question from somebody else is, I've heard that a new version of Hadoop is on the way.
So Hadoop in itself was an ecosystem where you can pretty much start off with, it was an open source technology. Apache was the main company which introduced it, but the value it was bringing was not that great. Uh, for data, creating data lakes, if you are using Hadoop for that, now you can simply do it on AWS, like S3 bucket. It's so cheap. You can just dump all of your data over there. So why would anyone want to invest and maintain another system when they can just have their solution on Azure Blob or AWS S3? If you've heard about new version of Hadoop, it might be true. It might come out, but I've used it. A lot of people in the industry have used it. I think a couple of years until couple of years back, it didn't even have update or delete option, which was, very primitive. If you're using data warehousing, you need to update stuff. It was just a mechanism to dump your data and that's it. They have introduced update and deletes for your data, but it's already too late for them. You have alternates you can use provided by AWS, like I mentioned, EC2 instances or HD Insight for with Azure. But again, as an open source, not a lot of users were using Apache Hadoop. They were using either Cloudera or Hortonworks or MapR. And now that you have other options, why would you even want to go with those companies, right?
Okay. Next question is from Mohammed Zain. What is the purpose of cluster analysis in data warehousing?
Cluster analysis,
Yeah.
uh, from what perspective?
Uh, that is not mentioned. So maybe you can come back to that question later.
Okay.
Um, so, uh, so another question around, is it beneficial to invest time in learning open source now? Cloud have their own proprietary implementations on top of these open source software, and they are much easier to develop and manage.
It depends. If you like, open source is always going to be there. Just remember that. Whatever proprietary solutions other companies provide, you still will have. It's a strong community and it's still growing. But and for as far as learning is concerned, never shy away from learning. If you want to learn, you can still spend some time in learning open source technology. As I mentioned earlier, most of the projects or most of the tools have the same steps. So even if you learn that open source technology, it wouldn't take you a long time to learn a different tool after that.
Okay. I think we covered the security aspect in the presentation as well, but there are like bunch of questions around security aspect, especially when you move from on-premises to the cloud. And there are a couple of questions from Kashif Ali and Abdul Samad asking about, the security of the data on the cloud, how much is it secure, how can we satisfy the regulators, and does the security get compromised when we move from on-premises to the cloud?
Right, and that's a good question. We hear that a lot. And one thing is, all the cloud providers say that they do provide another additional layer of security, but there have been hacks on the cloud where, and one of the things that my company is providing is security on the cloud as well. We just recently had a partnership with Snowflake. We can out of the box, using their external functions, protect your data while loading onto the Snowflake database. um, and that's something that definitely you need to keep in mind. You need to have an additional security layer. You cannot rely on the one that is available out there by the cloud provider, and that's why Snowflake did partnership with us. That is why AWS is partnered with us. Same goes for Azure. So you still need to have, and with the compliance policies these days like GDPR, CCPA, you definitely need to have a good security structure around the data that you're storing, regardless of whether it's on-prem or in the cloud.
Okay, sounds good. I think there's another question going back to the courses, or the courses that one needs to take. Somebody is asking about, if you go onto internet, there's so much of information around data warehousing that it gets a little overwhelming at times. So any personal recommendations for the content that a student should reach out? And then there's another question related to that if somebody is already graduated and they are in the industry, is there any particular field that they should pursue for getting maximum exposure to data warehousing?
Um, as far as someone it depends on what you like to do. If let's say someone is a programmer, uh, which industry are they working for? I would say start off with the same industry that you're in. If let's say you're working for a manufacturing company and you're writing code, and you want to get more into data warehousing, become a business user or business analyst for that company. Start to understand what value is being provided with the data that you have in that particular industry, and how can you improve on the available data that you have. Using that data, how can you improve the processes within the company? uh, Industry wise, it generally helps because you understand the industry and then you can learn something new. But if you move to a completely different industry, then learning that industry as well as learning data warehousing would be a bit difficult.
Right. Okay. Najam Bajwa, thanks for the great session, Muneeb. Since there are many cloud options available nowadays, is there an easy way to compare each of them from features and pricing aspects?
So that's a good question. Generally, the way it depends on multiple factors. First of all, what sort of setup that your company has. If let's say they already are supposed to go with AWS and they cannot go with anything else, then you're pretty much locked in. You cannot do anything else. But if they are open to deciding, then you can perform POCs with different vendors, and you can have benchmarks to see which one has much better uh, processing, and which one is going to meet your SLAs on a daily basis. So there are multiple things that you have to keep in mind. But I would say you start off with uh, performing POCs with different vendors, and checking with other companies in the industry, and see which vendor did they go with and what was the main deciding factor.
All right, sounds good. I think we are right on 1 hour mark, so that's great. I think we had a good Q&A session towards the end as well. As as you can see on the slide that is right now up, Muneeb has graciously shared his email address and his LinkedIn account as well. So please feel free to reach out to him if you have any question, and I'm sure he would be more than happy to answer all the relevant questions. With that being said, thank you, Muneeb, once again. It's been a great pleasure, working out with you and for arranging this webinar. And I think it went great. And thanks again for taking our time. Really appreciate it. And with that being said, we'll sign off for now. Thank you. This is again, thank you everyone for joining. And I hope this was a valuable and helpful session to you guys. Thank you and Allah Hafiz.